So this is a video going over what we need to know about triangles. So I wanted to first talk about the ways we classify triangles, and this was in your other video notes, but we also just want to make sure everybody's got it, that there are 4 words that we use to classify triangles by their angles, right? So if they're all acute angles, it's an acute triangle. If it has an obtuse angle, a right angle, or if all the angles are the same, we get these terms to classify triangles by the angles, okay? We also can classify by the sides. So that means if we have no congruent sides, we call it a scalene. 2 of the sides are congruent, we call it isosceles. And if all 3 sides are congruent, equilateral. Equa meaning equal, lateral meaning sides. So equal sides. So remember, we've talked about congruent. Congruent means equal, right? So no equal sides, 2 equal sides, 3 equal sides. So it's important to know that acute, obtuse, right, and equiangular talk about the angles, and then scalene, isosceles, and equilateral talk about the sides, okay? Okay, so a couple other things to go over quickly. If I'm looking at this picture, I just want to point something out. So this question says, which side is the shortest? Well, we're gonna use these angles to help us. If you notice, this 34 degrees is the smallest angle, okay? So it's always gonna be the smallest angle that's across from the shortest side. So this side here, DE, would be the shortest side because this angle is the smallest angle in that triangle, okay? All right, looking at this one, which angle is the smallest? Well, now I can kind of use the converse of what we just said. If I know that this is the shortest side, then the angle across from it is going to be the smallest angle, okay? So just like we saw in the last example, smaller angles are across from shortest sides. All right, well, what about this one? Remember in the video we talked about how these dash marks mean that those sides are congruent. So this side is the exact same length as this side. Well, this question asks us, what do we know about angle B and angle C? Well, because these 2 sides are congruent, then these 2 angles are also going to be congruent. So this angle, angle B, is going to be the exact same size as angle C. And that's important because if you see an isosceles triangle where 2 sides are the same, you're also going to have 2 angles the same, okay? Or here, if you see that 2 angles are the same, well, then that's going to mean that these 2 sides are also the same, okay? So 2 angles the same is also going to be a clue that you have an isosceles triangle. All right, well, what about this one? If I have 3 sides the same, then I'm also going to have 3 angles the same, okay? So 3 sides the same, we call equilateral, right? Equal sides. Well, if it's equilateral, it's also equiangular. The angles are also going to be the same, okay? So for example, this one, if I see that 3 angles are the same, I automatically know that the 3 sides are also the same, okay? So again, equilateral and equiangular are always going to go together. Oops. Okay, so you're going to see quiz questions like this where you have to classify by sides and by angles, okay? So I'll do the first one. Actually, I'll do B here since you already saw one of those answers. All right, so I'm noticing in this one that I have 2 sides the same, right? 2 angles are also the same, but we're going to classify that as isosceles, right? Because 2 sides are congruent. And then angles, well, it looks like all my angles are acute. They're all less than 90. So it's an acute isosceles triangle, okay? All right, so we have a few more to do. I wanted you to pause it and you jot down classify by sides and by angles for this pink one, and then we'll hit play and check. Okay, so it's scalene because I noticed that all three angles are different, then I know all three sides are also different. So 3 different sides makes it scalene, and then it has an obtuse angle up here, so obtuse. Okay? All right, try a couple more. So classify these, pause, and then we'll check the answers. Okay, I have isosceles here because 2 sides are the same, and a right triangle because it has a right angle. Number 2 over here, the purple one, equilateral, all 3 sides are the same. Equiangular because all 3 angles are the same. Okay, last 2, do these, so pause and then play when you're ready to check. Okay, here's what I got for these. All right, we're going to also just mention here, this was also in your video, I showed you in video 4 that all triangles are always going to add up to 180 degrees. So that's something else we're going to remember as we work with triangles in this chapter. So, quick little summary. After going over these slides, we should have noticed, right, that when all 3 sides are the same, we also know that all 3 angles are going to be the same. Okay? And then if all 3 sides are different, then all 3 angles are going to be different. All right? And if 2 sides are the same, then 2 angles are going to be the same. Okay, so that's just something that we need to kind of recognize about triangles. So I want you to turn now, and I'm going to switch over so you can look at it. You should have a triangle packet, and the front side says Big Ideas About Triangles. Okay, so I want you to take a minute to find this paper. All right, and I want you to work with your neighbors quietly, just in your seats, and try to answer these questions here, 1 through 12, and also classify these triangles, right, by sides and by angles. Classify those. So we're going to pause here for a little bit and get everybody time to work up to here, and then when we're ready, I'll come back and go through these answers. If you need to skip 1 or 2, that's fine, and just be ready to write it in as we go over them here now. So pause if you need to, and then we'll go over these. Okay. So a triangle has 3 sides, 3 angles, and 3 vertices, right? Vertices is the plural of vertex. So 3 corners, 3 angles, right? 3 little tips. We can classify by angles and by sides. I'm going to go through this quickly, so if you need to pause and catch up, please do that. Right, this is what we copied down in our notes, and we already went over it. You need to know what the words are to classify by sides and by angles, okay, because you're going to have quiz questions on those. We know that triangles add up to 180 degrees. We know that bigger angles are across from bigger sides, and smaller angles are across from smaller sides. Please pause if I'm going too fast. If none of the sides are the same, then none of the angles are the same, and that would make it a scalene triangle. If 2 angles are the same, then 2 sides are the same. That would make it an isosceles triangle. If all 3 angles are the same, then all 3 sides are the same. This would make it equilateral and equiangular. Okay, we name a triangle with this triangle symbol and then 3 capital letters, whatever the vertices are, right? So if this is like point A, B, C, I'd call that triangle ABC. Okay, this one you may have skipped. All right, we're going to talk about this a little bit more now, but I want to make sure you have this written down. Number 12, when we construct, so when we draw our own triangles, we could get that there's only one correct triangle that works, right? Like if it's very specific, it has to be this exact thing. We call that unique. Okay, they're all going to be identical or they're all going to be congruent. We could also get answers that are the same shape but different sizes. Okay, so we call that similar. And basically this means same shape means they have the same angles, but they could be different sizes. Okay, so an example might be like this right triangle and then one that's a little bit bigger but still the same shape. Or it's possible that we could get many totally different triangles that work, right? If all I do is ask you to draw an isosceles triangle, we could all have something completely different and it would still be right. Okay, so we'll talk more about this, but I wanted you to get those filled in. All right, and then we should have also classified these triangles. Okay, so 2 words, right, classified by angles and by sides for each picture. Okay, I want to take some time now to do some constructions. All right, I'm going to go through these on the video and do your best just to keep up and draw them with us here. Okay, so construct a 4 centimeter side and a 5 centimeter side that meet at a 70-degree angle. Okay, remember we always draw our line first, put a vertex on it. Let's just do this 70 degrees. So I'm using my protractor to draw 70 degrees. 70 degrees. Okay. And then it says I want 4 centimeters and 5 centimeters for those sides. So you'll notice right here on my protractor I have centimeters. So let me do 5 centimeters and make a mark. 4 centimeters and make a mark. Okay, and you can watch this through and then maybe pause and let everybody catch up. But if I connect those, I've got my triangle. Okay, so we know this was 70 degrees, but I want you to also label 5 centimeters, 4 centimeters, and we need to measure these other angles. Okay, so I'm going to move my protractor over to this one and measure this angle that I drew, and it looks like about, what do I get, 45 angle or degrees there. And I'm going to spin my protractor around and put it on this vertex and try to measure there, and I get 65. Okay, and there's a couple things I want to talk about once we all get this drawn. Okay, the first thing is that these 3 angles should add up to 180 degrees, and mine do, so that's good. It means I probably measured them right. Okay, and the second thing is I want you to look at my paper and your neighbor's paper, and we all should have the exact same thing. So this is an example of unique triangles, unique answers. This is the only one that will work. Right, if you come back up here where we wrote down unique, okay, only one correct triangle that works, this guy, right? Because it told me how big and what angles to use, we are all going to get exactly the same thing, okay? Let's try one more, a right triangle with 40 degrees. So, I'm going to draw my line, vertex, a right angle. I'm going quickly for the video, but pause if you need to. Another vertex, and let's put our 40 degrees. Okay, so there's my 90. Here's my 40. I connect those, 40. All right, well, we need to measure this other angle. Spin your protractor around. Okay, and I get, right about 50, which is good because it should add up to 180. Okay? All right, so let's talk about this one. It didn't give us any lengths, right? Maybe you look at yours and it's a little bigger or a little smaller. Well, we had up here same shape, same angles, but different sizes. So this one is similar. Right? Our answers will be similar to each other because they're going to be the same angles, but they could be a different size. Okay? Okay, I want you to still try constructing this one. You can try this one. The D one here is a little bit tougher, so if you get stuck, you can skip that one. I want to just look at a couple of these because you're going to try to finish as much of this packet as you can, right? Use the protractor as much as you can while you're in class, so that you can also do probably these ones at home, okay? You want to get the protractor ones done while you're here. So we'll actually come back to these more. You can try them or just move on to constructing here, page 5 and 6, you're doing more constructions. Okay, so I'm going to stop the video here, and you're just going to keep working on this packet. Get as much done as you can, because the whole packet is going to be due on Wednesday. Okay?